This is 11B notes. We're going to be talking about angles and radian measure. Alright, so we reviewed your trig from geometry during 11A. So now we're going to be moving more into the new material for our trigonometry unit. So trig kind of has a language of its own. So we're going to spend a lot of time with vocab today. Alright, first of all, the definition of trigonometry deals with the relationship between sides and angles of a triangle. Now, in the past, you've dealt with what we call degree measurement for an angle. We're going to introduce a new unit of measurement today called a radian measure. So the definition is measure of an angle in standard position whose terminal side intercepts an arc of length r. And it's usually expressed in terms of pi. All right, let me show you an illustration of this. Like I said, the definition itself doesn't make much sense to you, but let's look at the following demonstration. Okay, so we have the circle. Alright, so we have the length of the radius of this circle, BC here, is 4.01 centimeters. Nothing special about that. Okay, what is special though, we're going to make a radian measure. We're going to measure the angle that the angle DBC makes in radian measure. So when the radius is equal to the length of the arc, then that's a radian. That's 1 radian. When the radius is equal to the length of the arc. Notice they're both 4.01, 4.01. Alright, so now the question is, why do we typically represent radians in terms of pi? Okay, let's see what happens here. So that's 1 radian. So when are we going to have 2 radian? What's the length of the arc going to be to have 2 radian? Hopefully you said 8.01. Okay, so let's look at that, 8.01. So I'm going to move this. Actually, I get to go back to my computer to do this. It does not let me do it on the screen. Alright, let's see if I can do this. Alright, so we're going to move that arc until we make the length of this arc CD 8.02. Okay, so that's 2 radians. Alright, so what would 3 radians be? Well, hopefully you're going to say 3 times 4.01, which is going to give us 12.03. Okay, so that's going to, let's try to move the length of that arc to 12.03. Notice we're oops, I had it there. There we go. That's 3 radians. So notice that's 1, 2, 3, and halfway around a circle, we have a little bit left over. Alright, so what number in math is 3 and a bit? Well, hopefully you said pi. So that's why half of a circle is pi radians. Because any radius is going to go halfway around that circle pi times. Alright, so like I said, this doesn't make sense to ask me in class. And it doesn't matter what size I make that circle. I can make my circle smaller or larger. Notice how, like I said, we're still staying there at 3 radians. So 2 times 3 is 6. Okay, so halfway around a circle is pi. All the way around the circle, so pi plus pi is 2 pi. So 180 degrees is equal to pi. 360 degrees is equal to 2 pi. Alright, let's go back to our screen up here. Let me minimize this. Okay, so that's what a radian is. When the arc measure is equal to the radius measure, that's 1 radian. So here, like I said, let's put some stuff on our circle here. So here we start at 0. Here's pi. All the way back around is going to be 2 pi. Alright, so what's 90 degrees? Well, how much of the circle have we got? So we've got half of pi. So that's pi over 2. Half of pi. Okay. Alright, what's 270 degrees? Well, how many? So we've gone pi and another quarter. Right? So that's 3/2 pi. So those are your quadrant angles. So 90 degrees is equal to pi over 2. 180 is equal to pi. And 270 is equal to 3 pi over 2. This is 90. Okay. Like I said, if you have a question on a radian, we can discuss it more in class. All right, so let's look at what we're going to be doing. One thing you're going to have to be able to do is convert between radians and degrees. So if we've got degrees and we want to turn it into a radian, we're going to put, I always think about the way to remember this is I'm going to put the pi in. Radian tends to have pi as part of the answer. So I'm going to take my degree measure, and I'm going to multiply by pi over 180, 180 degrees. So that's going to change a degree into a radian. All right, what if I have radians and I want to turn it into degrees? Well, I want to get rid of the pi. So I'm going to take my radian, and I'm going to multiply by 180 over pi. I'm dividing the pi out. All right, let's look at a couple of examples. I want to convert to radians. I've got 75 degrees, and so I'm going to multiply by pi over 180. So I'm going to get 75 pi over 180. My degree measurement's gone now, right? Degree over degree equals 1, so that's gone. Simplify the fraction, and I'm going to get 5 pi over 12. All right, let's go the other way. I want to convert degrees. I've got negative 5 pi over 4, and I want to convert that to degrees. So I've got negative 5 pi over 4 times 180 over pi. All right, my pi over pi is 1, so my pi is going to divide out, leaving me with negative 5 times 180 over 4. Simplify this, and you should get negative 225 degrees. Okay, so you need to memorize those two little formulas. So radians, from degrees to radians, you're going to put the pi in, and from radians to degrees, you want to take the pi out. All right, some vocab. The initial side, so angles in standard position. Standard position, what does that mean? Well, first of all, you need to know what your initial side is. Your initial side is your starting position. It's typically the positive x-axis. So your starting position, to be in standard form, you're going to start your angle there at 0. Your terminal side is where the ending position after you rotate, and it determines what quadrant you're in. Now remember from geometry, our quadrants are 1, 2, 3, and 4. Alright, so if I want to sketch 100 degrees, alright, we're going to rotate, well, this up to here is 90, so I'm going to go like 10 degrees more. So this is going to represent my 100 degrees. So here's my initial side, and then here's my terminal side. Since my terminal side is in the second quadrant, we said that this angle lies in the second quadrant. And that's going to come into play when we start doing some math with this stuff, determining the signs. Okay, now measuring angles. Positive angles go in the counterclockwise direction, abbreviated as CCW. That's a positive angle. So if it rotates in the counterclockwise direction, that's a positive angle. If it rotates in a clockwise direction, that's a negative angle. So if we start here and go back around this way, all right, this would be a negative angle. How much? Well, all the way around a circle is 360. 360 minus 100 is 260. And because we're going in a clockwise direction, that means the angle is negative. Negative and positive in angles is just the direction around the circle that you're rotating. Alright, so let's sketch a couple of these in standard position. Alright, so let's start off by drawing yourself a little quadrant. Alright, we're going to start on our initial side. Always going to be on the at x equals 0. Alright, we want negative 315. So that means I'm going to be rotating in the clockwise position. Alright, so where are we going to end up? Well, all the way around is negative 360. All right, up here, this is negative 270. Let's go around this, negative 90, negative 180, negative 360, going in that direction. Don't forget your degree symbols. All right, so 315 is going to be in that first quadrant. And so this is going to be negative 315 degrees. And you need this arc to show you what direction you're going in, because that's going to determine the direction of your angle and where it's going to end up. So that would be an angle in standard position. All right, how about pi over 4? All right, here again, draw your axes. We're going to start at 0 on our initial side. All right, pi over 4. Well, we know this is pi over 2, 3 pi over 2. All right, so I want pi over 4. So I want halfway in the first quadrant. So here's pi over 4. So this angle lies in the first quadrant. All right, how about C? Once you take a moment, you try that one. All right, if you're not done yet, pause the video because I'm going to work it out. All right, here again, we're starting in the initial position. It's negative, so I know I'm going clockwise. All right, so this is negative pi over 2, negative pi, negative 3 pi over 2. All right, pi over 3. That's 1/3 of my way around my circle, 1/3 of the way to pi. So approximately about there. I'm breaking pi into thirds. So negative pi over 3. This thing I said, think about radians as a proportion of your circle, a proportion of pi. That's an easy way to think about radians. All right, like I said, we're heavy on the vocab in this unit. We'll start doing the application next time. All right, new vocab word, coterminal angles. We'll look at what the word coterminal, same terminal. So angles that have the same initial and terminal sides, so coterminal angle. And we're asked to find a positive and a negative coterminal angle for each. All right, so let's look at what, we're going to come up with a little formula here to do this. So if I've got a negative 100 degrees, all right, I'm going in this direction, so it's here. So there's my negative 100 degrees. All right. I want to get, so here's my initial side and my terminal side. I want to get another angle that has the same initial and terminal side. Well, what's an easy one? Just go the opposite direction. So let's go around the opposite direction. So here's one. And since I'm going counterclockwise, that's a positive angle. So that's a positive, what, 360 minus 100 is 260. So positive 260 degrees. So I've done half my work there. There's my positive one. All right, what was the math there? What did I do? I added 360. So negative 100 plus 360 degrees gave me my 260. All right, how do I find another one? All right, I can go in the same direction. I can go more than one turn. So if I go in the same I need a negative one now. If I start here, my initial side, go all the way around my circle, that's 360 plus 100 more. That puts me back at my same angle. All right, so you can go around the circle more than once. So that was my original angle plus one full turn in the negative direction, so negative 360. Add those together and I get negative 460. There's a negative angle. And you can keep doing this. You can keep adding and subtracting multiples of 360 to get an infinite number of coterminal angles. All right, let's look at negative 2 pi over 3. All right, so let's draw a visual of this. Sometimes it's better to have a visual. All right, so I'm going in the negative direction, negative 2 pi over 3. So I'm in my initial side. All right. All right, so here's pi over here, negative pi over here. This means, think about this as 2/3 of pi. So here's 1/3 of pi. Here's 2/3 of pi. So here is my negative 2 pi over 3. All right, how are we going to get more angles? Let's do the easy one. I always think it's the easy one. Go the opposite direction. So let's get this one, that coterminal angle. All right, how are we going to get that? We got our original angle, and we're going to add, now instead of 360, we're in radian measure now. 1 time all the way around our circle is 2 pi, so we're going to add 2 pi. And you just treat this as a fraction. So we're going to add, so 2 pi plus negative 2 pi over 3 is going to give us 4 pi over 3. Okay? All right, let's look at another one. Let's go around the circle and back. Let's go in the same direction. So here, I'm going to go in the same direction. So I go all the way around 1 time, plus my negative 2 pi over 3 more. So negative 2 pi over 3, all right, and then I'm going in the negative direction, so I'm going to plus a negative 2 pi. Add these together, and I'm going to get negative 8 pi over 3. And here again, you can still keep adding multiples of 2 pi and negative 2 pi and get infinite number of coterminal angles. All right, take a moment and just practice sketching that 5 pi over 4 in standard position, and then we're going to find the coterminal angles for those. If you need more time, pause the video. All right, so let's see what I've got. So think about this. We're going in the positive direction, so we're starting here. Okay, so this is going to be, up top is pi over 2, pi, 3 pi over 2. All right, 5 pi over 4. That's 5/4 of my circle. So I've got 1, 2, 3, 4, 5/4. So here is 5 pi over 4. All right, so that's a third quadrant angle. All right, we've got to find the coterminal angles. Let's go the opposite direction. Let's go the negative direction. So I know this is going to be a negative. So I start with my original, and I'm going to subtract 2 pi for the opposite direction. So that's going to give me negative 3 pi over 4. There's my negative one. All right, let's go the positive one. That means I want to go in the same direction. All right, so I'm going in the counterclockwise direction. So I'm going to go 1 full circle and then pi over 4 more. So I've got pi over 4 plus 1 full circle. And that's going to give me 13 pi over 4. All right, like I said, if you come up with any questions, please jot them down now so you won't forget them when we come to class. Because like I said, I know this is completely new vocab for you. Something outside your comfort zone. All right, please add the following question. Add 760 degrees. Let's do one like that. Let me add, I don't have quite enough room here. Let me put another page in here. And we're going to do 760 degrees. All right, what is that going to look like? Where is that angle going to go? All right, well, selected. This is more than 1 time around our circle. So let's see, what is this? If I take 760, a better pink color, 760, and subtract 360, I get 400. That's still more than 1 rotation around my circle. So let's subtract another 360. I'm trying to figure out how many times does 760 go around my circle. So that's going to be 40. 400 minus 360 is 40. So what does that mean in terms of our problem? Okay, so we're going to start on the initial side. We're going to go around once, that's 360. Around again is 720. And then 40 more. So that's what 760 degrees, positive 760 degrees look like. It's 2 times around our circle plus 40 more. All right, so let's find another coterminal angle. Well, hopefully you see one right off the bat, right? Because we want to have the same initial and terminal side. So this angle right here is coterminal. All right, what's the measurement of that? Well, that's 40 degrees. How do we find it? It's 760 minus 2 times 360, which is going to give us our 40 degrees. So that's my positive one. Now I need a negative one. Well, subtracting's not going to work here. A single multiple of 360 because I'm still positive. So what do I need to do? I need to up my multiple of 360. So to find a negative coterminal angle, all right, I want to go the opposite direction. I'm going to have to go 760 minus 3 times 360. And that's going to give me negative 320. All right, so that's this angle going around this direction is my negative 320 degrees. So sometimes you're going to have to find coterminal angles. You may have to add more than one multiple of 360. All right, here again, like I said, if you have any questions, please write down so we can ask them in class. All right, a couple more things. Like I said, a lot of vocab in this particular unit. All right, let's talk about a reference angle. A reference angle is an acute angle formed by the terminal side and the nearest x-axis. So reference angles are always acute, they're always positive, and they're always to the nearest x-axis. So for example, let's use 100 degrees. Let's find the reference angle for 100 degrees. So 100 degrees lies about here. All right, so there's my 100 degrees. The reference angle is always an acute angle. It's always between the terminal side and the nearest x-axis. So that's my reference angle. Now since this is 180 degrees, the measure of my reference angle is going to be 80 degrees. It's always acute, terminal side to the nearest x-axis. This is going to come into play when we start talking about our unit circle, our reference angles. All right, so let's find the reference angles for the following. 7 pi over 4. All right, what does that mean? That's 7 quarters of our circle. So 7 quarters of our circle. So if I'm starting here, I've got 1, 2, 3, 4, 5, 6, 7. So my angle is here. That's 7 pi over 4. All right, where's your reference angle? It's caught between the terminal side and the closest x-axis, and it's in the positive direction. So my reference angle is this, that angle there. Terminal side and the closest x-axis. Now what's the measure of that? Well, all the way around my circle is 2 pi. So 2 pi minus 7 pi over 4 is going to leave me with pi over 4. So my reference angle here is pi over 4. It's going to tell us later on what family we're in. All right, let's look at 245 degrees. So here's 90 degrees, 180, 270, and back around to 360. So 245 is going to start on our initial side. So 245 is going to be in the third quadrant. So 245 is here. That's 245 degrees. All right, where's our reference angle? It's caught between the terminal side and the closest x-axis. So here's my reference angle. All right, how do we find it? What's the measure of that? Well, halfway around our circle is 180, so if I go 245 minus 180, that's going to leave me with 65 degrees. So my reference angle here is positive 65. All right, C, negative 45 degrees. So negative 45 degrees, I'm going clockwise. So here's negative 45 degrees. All right, what's my reference angle? It's between the terminal side and the closest x-axis. So terminal side, closest x-axis. So here's my reference angle. Why did I switch direction? Well, remember the definition said it has to be positive. It's a positive acute angle. So that means that my reference angle is positive 45 degrees. It's always positive, it's always acute. Alright, good practice. Take a moment, pause the video if you need to, but sketch 10 pi over 3 in standard position. And then we're going to find its reference angle. Alright, 10 pi over 3. That's 10 thirds of my circle. 10 pi over 3s. So start in terminal side. Alright, third of my circle. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So here is 10 pi over 3. We'll go all the way around once and then back again. Okay, where's my reference angle? Where is an reference angle? It's always between the terminal side and the closest x-axis. Always the x-axis. Alright, how do we find that measurement? Well, because we went around our circle, how many times do we go around our circle? We're going to have to subtract that. So we're going to go 10 pi over 3 minus 3 pi. So we ran around our circle 3 times, which is going to leave us for our reference angle of pi over 3. So our reference angle here is pi over 3. Here's our reference angle. Alright, like I said, here again, like I said, very important concept, so please make sure you understand this. Please ask me questions if you don't. Alright, you need to probably get another sheet of paper somewhere else. I don't think I've kind of jam-packed these set of notes, but we need to add these couple of concepts that weren't on the original notes. We're still going to do sector of a circle, so don't write in that area. But just from geometry, remember that supplementary angles, sum of two angles are equal to 180 degrees or pi radians. And if you're asked to find the supplement of an angle, you want to know what angle plus 5 pi over 7 is going to equal to 2 pi. I'm sorry, not 2 pi, pi. Because it's 180 degrees. 2 pi would be 360. Alright, so how do I find? So I've got one angle. So I need to take away, so I'm going to take pi, subtract 5 pi over 7. Alright, so here I get 7 pi over 7 minus 5 pi over 7. So the supplement is 2 pi over 7. Because 2 pi over 7 plus 5 pi over 7 equals 7 pi over 7, which is pi. Alright, let's find the supplement in degrees. So here again, 180 degrees. So 180 degrees minus 120 gives us 60. So 60 is the supplement of 120, because 120 plus 60 equals 180. Well, when you talk about supplementary angles, of course you got to talk about complementary angles. So complementary angles, sum of two angles equals 90 degrees or pi over 2. So if we're asked to find the complement of 3 pi over 2, I want to know what plus 3 pi over 2, 3 pi over 7 is going to equal pi over 2. So I'm going to take pi over 2 and subtract 3 pi over 7. Alright, common denominator here. I'm going to get 7 pi over 14 minus 3 pi over 7, which is, nope, got to change that second fraction too. Sorry, I got distracted by something outside. Alright, let's try that again. Let's see, what's that? 6 pi over 14, which gives me, when I subtract, I'm going to get 1 pi over 14 or pi over 14. Alright, let's find the complement of 42 degrees. So I'm going to take 90 degrees and subtract 42 degrees. So 90 degrees minus 42 is going to give me 48 degrees. So 48 and 42 are complements of each other. All right, so like I said, please add those to your notes. All right, last stuff with the vocab. Talk about a sector of a circle. We're going to find arc length and the area of a sector. Well, remember, a sector is like a wedge out of your circle. So the area of a sector is going to be that wedge. Okay? And then the arc length is the length of that arc. All right, that's the difference. We talked about that in geometry too. All right, we're going to be using theta, and theta is an angle measurement in radians. So it's an angle in radians. Our formula only works if we have it in radians. So we may have to change depending on what we've got. If we've got degrees, we have to turn it into radians. The arc length is equal to the radius times theta. And the area of your sector is equal to 1/2 r squared times theta. Remember, here again, theta is always in radians. All right, so what do we've got? Let's look at our example. You're creating a flower bed that is a sector of a circle. All right, so we got this flower bed that's going to be some kind of sector of our circle, not drawn to scale here. You need to buy paving stone for the curved edge of the flower bed. So you're going to cover the curved edge in some kind of stones. That's what we're talking about here. Okay? All right. Find the length that will be covered in paving stones. All right, first of all, one thing in here that we need that we're not giving is our angle measurement. Okay? So we need an angle measurement here. I'm going to say this is 60 degrees. So the first thing you need to do, we're going to find the length. We want S is equal to R times theta. We also need the radius of our circle. So our radius here is, say, at 5 feet. This will all be given to you in the problem. All right, first thing you have to do is change that theta to radians. So theta is going to equal to 60 degrees times pi over 180, which is going to equal to 60 pi over 180, which is equal to pi over 3. So the length of the curved area is going to be our radius, which is 5, times pi over 3, which is going to give us 5 pi over 3 feet, because there's still linear measurement here. Well, if you go to Home Depot and say, give me 5 pi over 3 foot of the stone, they're probably going to look at you like you're crazy. So what are we going to do instead? So how much stone am I going to buy? What can we use for a decimal approximation for pi? 3.14 over 3. So here's one chance where you want to change pi to 3.14 times 3.14 divided by 3. All right, so that means we're going to need approximately 5.233 feet of stone. So you're probably going to buy, what, 5.5 feet, all right? Or 6 feet of stone. All right, let's find the area of our sector. Our area is equal to 1/2. We're going to cover this thing with mulch. How much mulch am I going to need? Or if I want to cover with that black paper, so I need something linear, okay? With my radius squared, which is 5, times my theta, pi over 3. All right, here again, what am I going to get? I'm going to get 5 squared is 25 pi over 3 times 2, which is 6. All right, what's my units here? I squared my feet, right? So I've got square feet. Here again, like I said, you're probably not going to buy it in terms of pi. So let's change pi to 3.14. And I'm going to need 13.0833 square feet of mulch or paper, that kind of thing. If my mulch has any depth other than 1, then that's a cubic unit. But anyway, that's getting to something else. All right, like I said, if you have any questions, please let me know. We'll talk about it in class.